So you see, what you can do is you can use radiation. What you can do is you can put some radioactive material in the water. And then you can walk on the ground with the Geiger counter and go click, 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 and like, here it is.
But the water won't be polluted.
You put a little bit.
Oh.
Not so much.
But I think pollution.
That's what he said, yeah. So just put a little bit. Not too much. Anyways, the people can't drink the water because there's no water in their home. So, it's not so bad. But I'll show you what we have a look at now. So you need a material with a big half-life or a small half-life? Small.
Yeah.
So what they use is fluorine-18. Its half-life is 2 hours. Now wait. I don't need you to write all of this down. It's not important for the exam. So it's enough just to say fluorine-18 with half-life 2 hours can be used to find leaks in pipes. That's enough. Pipes, these are pipes. Wait, what do you call them?
I don't know.
Well, they're called pipes. P-I-P-E-S.
Oh.
Do you?
How about
Yes, you could just say fluorine-18.
No, I mean the
Americium? Curium? Yeah.
What's the half-life?
Oh, the half-life for that one was 400 years. Okay, what did you write, Summer?
The fluorine-18, the half-life is 2 hours, will be used the leak of the pipe.
Can be used to find the leaks of the pipe. Okay. Next application is medicine. Technetium 99M, half-life 2 hours. Now, this one here is used. It's used to get a picture of the inside of people.
It's like the magnesium.
Yeah, it's like the MRI. Yeah. Now, do you notice how in the picture there's some places in his body where there's more technetium? So you notice he has a lot here, 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 and here, and here, and here. Why?
I just know why it's here.
Yeah.
Here.
Yeah. Why?
Because it's
Yeah.
I try to translate. It's the technetium inside of our body.
Yes.
The technetium will go through.
Yes.
Of our bodies, and here is the technician will be it's very difficult.
I know. You know. So here and here and here under your arms as well, these parts of your bodies, they try to clean your body. So the technetium is foreign. The body tries to remove it. It removes it here, tries to remove it here, here, and also here, your liver. It tries to filter, clean it out. Okay? So you can use this here maybe this person, there's something wrong with his liver, and you want to see if there's any problems.
Where is problems?
Huh?
Where else? Just so you can see the picture and find where it's a problem.
Exactly.
Yeah.
You can see the picture where's the problem. So, for example, I don't know, maybe this is a problem here. Or maybe, I don't know, maybe this is a problem, I don't know. You can get a picture of the inside and see if there's any problems. I don't think there's much more to say. This has a short half-life, 2 hours, because you want it to very quickly become non-radioactive. You know, has anybody ever had this before? No. No. It's like what you said. It's like MRI. Did you learn about this in?
No, I just know this.
You've heard of this before.
Yeah.
It's similar to this. So what you could write down is this was in one of the exams recently, not physics exam.
It's a chemistry exam.
Something like
I thought it's biology.
biology exam. I think this material was in it. Anyways, you could just say technetium 99M with half-life 2 hours is used in medicine for what word would we use? It's used in medicine for
X-rays.
good, but we need a word that kind of means everything. MRI, X-rays. That's too general. We need a word that means MRI, X-ray, picture, and read all of this.
How to say the word type of the maximum with the gamma rays and alpha rays.
Okay, no, it's okay. I'll tell you. So we can say technetium 99M, half-life of 2 hours, is used in medicine for imaging.
How to spell?
Well, you know image, I-M-A-G-E.
Yeah.
So imaging,
I-M-A-G-I-N-E.
G. Yes, I-N-G.
I-N-G.
Yeah, imaging. Yeah. So imaging means X-ray, MRI, CAT scan, all these things. Yeah? Is it okay somewhere?
Yeah.
Alright, next one. Cobalt 60. Cobalt 60, half-life 5 years, is used for security. You know, like at like an airport, or you know, like it's kind of like an X-ray. Can you see?
Yeah.
But it gives you a more detailed picture. Yeah? So you could just say cobalt 60 of half-life 5 years is used in security imaging.
Security.
Mm-hmm. You know security? Like airport security, police. Yeah. Yeah. You see here, these is like army, military. See, it's a gun here. Ah, yeah, that's a gun. Look at it.
Just a truck with a weapon.
Yeah, inside. Yeah. These could be terrorists. You don't know. Machine gun, isn't it?
No.
You don't think that's a gun?
It's
What?
just a machine.
Just a machine.
Yeah. So you know there is a table and with some machines on that you can make some little things
The whole diagram looks like
and fix some things
Yeah.
in that.
Okay. All right. It's not a gun. It's only a machine. Fine. And yeah, it's inside a truck. Yeah.
Use for something.
Yeah. Do you know security? Police. You know police. So it's used for police imaging. Like at the airport. You know at the airport? They take a picture of you.
Okay.
It's used like this.
Oh, I know.
Yeah? Yeah?
Yeah.
Okay. Next one. This one here, this is boron 10. Well, actually, hang on, maybe, do you need this one? No, you don't need this one. This is two biology. Two biology.
Oh.
This one I think is good, because this could be like EAP. Food irradiation, cobalt 60, half-life again, 5 years. So you saw cobalt 60 a moment ago was used for security. But it has another use. It can be used for farming, in the farm. So what happens is, you know, like if you have your apple. What happens to your apple if you leave your apple on the table? Well, it turns brown.
Yeah.
Dries up. It turns brown. Why? Why does it turn brown and rot?
So oxygen.
Yeah, but why does that make it turn?
So
Why does it start to smell?
starts the.
Why does it rot?
Apple.
Yeah. Well, because you have little bacteria that live on the outside and they eat it, right? If you have a piece of meat and you put the meat on the table, after one day it will start to smell because the bacteria that live on it, they start to eat it, right? So you would like to kill the bacteria on it. So how do you kill it? You use cobalt 60. You put the cobalt 60 on the food, the radiation, and it kills what lives on the food. Yes?
So the half-life is 5 years.
Yeah.
It's good for our healthy.
Well, that's a good question. So you need to think about it like this, Summer. Which is better? This, or maybe you get very sick if you eat some apple? You know, if you get, do you know food poisoning? Food poisoning? You eat the food and it makes you very sick. Food poison? You know
Oh
this?
yeah.
This is very serious. You know, it can make you very, very sick.
Yeah.
Could kill you.
Yeah.
So it's like, which is better, this or food poison? It's difficult.
No one is better.
You have to eat.
Yeah.
So what do you do?
It's fresh.
But everything has
Yeah.
bacteria on it, you know.
They live in the garden or in the farm.
No, farm's probably worse. Farm is probably full of bacteria. You know, cows, horses, everywhere, you know. Horse poo, cow poo, it's everywhere, you know. Dog poo, everything.
How to spell bacteria?
Oh, so what you could know, so what you could say, Ben, is cobalt 60 is also used to, let me get my spelling right, irradiate? Is there an I here?
That's what
Yeah, but that's irradiate. Okay, no, I won't use that word, and I don't know how to spell it. Cobalt 60 is, no, this is right. Cobalt 60 is also used to, let's just say, kill there's the spelling Ben, bacteria that lives on food. So here's your food. Here's your cobalt 60. And then the radiation on this, it kills whatever is living on your food. Kills it. Makes it clean. Yeah? Okay. Right. And the last one, and this one is important for the exam. Carbon dating, C14. Okay, this is very, very important. So here's the idea. Everything that's alive has C14 in it. When it dies, the C14 decays. The half-life is 5,000 years. So, if you measure how much carbon 14 there is, then you can get the time. So you can know when they died. So if it was alive, then it had full C14 in it, and then when it dies, the C14 it decays. Okay? So for example, if you find an old book, well, the book is made of paper, isn't it?
Yeah.
And the paper came from trees. And the tree died to make the book. So you can know how old the book is. You know? So like this table, you can measure the C14. Another example, maybe long time ago they find people and they find little fish with them, and maybe they find some, I don't know, some ancient ruin, some old building underground. Because you can measure the C14 in these, you can say something like, oh, these people were from 10,000 years ago. Something like this. Yeah? So, this is where does the C14 come from? So what happens is, I think you have nitrogen in the air, and then from outside space you have neutrons, and the neutrons hit the nitrogen, and then I think, oh no, how does this work? It makes carbon 14. I don't remember. Anyways, what you need to know is the carbon 14 is in the air. So what happens is the carbon 14 gets into the tree and into the grass. And the animals, they eat the grass or the tree. They have carbon 14 in. And then the humans, they also eat the animal and the plants. So everybody gets C14 in them because it's in the air. Okay? So, radiocarbon dating is a dating method that uses carbon 14 to determine the age of carboniferous materials. Maximum age is 60,000 years. You can't use it after 60,000 years because the carbon 14 is too small. Because 60,000 years is 12 half-lives. It's too many. Okay? One of the frequent uses of this technique is to date organic remains from archaeological sites, like what I said, underground. So maybe we want to make the English a little bit easier. So what you can say is C14 with half-life of 5,000 years is used to date things which have died, e.g. human, animals, plants, etc. And the reason this is because all living things have C14 in them.
So the daughter will know how long the people die.
No, because it's plus or minus 100 years.
Okay.
So it's not good for short time.
Okay.
Yeah. So you could say something like, Ben, like this book is 2000 plus or minus 100 years old. You could say that. Something like that.
Book.
Book, yeah.
2000
Yeah.
Book.
Yeah.
The paper will destroy
No,
into 2000 years.
No.
They will become the.
No. Google this. One L or two. Try that.
What? DEAD.
DEAD. Dead.
Dead.
Yeah, Google that.
That's the.
So.
Scroll.
What?
This book is very old. It was found in 1946, but it dates from what year?
Created in EST 408.
408.
Yes. EST 408.
Yeah, BC.
BCE
Yeah, BCE.
231.
BC
What?
231. That's about 2,200 years
Yeah.
ago. Yeah.
Oh my god.
So you see, it can last. Now, summer.
Yeah.
The reason it lasted so long was because it was inside a pot. The pot was closed,
Oh
so they were inside it.
yeah.
You know.
If it's in the air, it's
It's-
right.
Yeah, it is a problem. Yeah, but if it's inside a pot,
Yeah.
it's okay. All right. So you see, for this lesson, it's just English.
Yeah.
Yeah. What have we got? Ah, yeah. We'll finish there. You can fill these in later for tomorrow or when next physics class. Okay. Oh, and you can bring your laptops for Friday.
It's not Wednesday or Thursday.
Whatever the last class is. Last physics class.
Yes.
Last?
Oh, Ben, did you email me?
Yeah.
You had trouble with your,
Very
yeah, you have trouble with the word count.